Good morning everyone. Thank you so much for tuning into this video. This is the third video in our log series, and this video we'll be talking about a little bit of laws about subtraction of logs. So let us have a look at the laws of logarithms once we subtract two logs. So our rule is log x to the base a minus log y to the base a is equal to log x over y to the base a. Let's test this law. I mean, I have tested it, but I just want to test it in front of you guys to show that yes, it works. So this is our question. Log 27 to the base 3 minus log 9 to the base 3 is equal to log 27 divided by 9 to the base 3. Now if these two sides of equations are equal, which is the left hand side and the right hand side, that means that this law is absolutely correct. So let's focus on the first part of our question. So let's take log to the base 3 27 is equal to how much? Okay, so log 27 to the base 3 is equal to how much? Now in our previous videos we have already learned this, that this 3 is the base and this 27 is the output, or we can say answer, and this is equal to x, which means the power. This is how we write log form. So this is equal to the base 3 to the power x is equal to 27. So 3 to the power how much equals 27? So 3 to the power 3 is equal 27. I mean, you don't need log to find this out. It's like pretty simple. It's 3 times 3 times 3, so 3 to the power 3 equals 27. So we know that log 27 to the base 3 is equal to 3, so x is 3 because x is the power. And if you don't know how to convert between index form and log form, I've already done a video. You can just go back and watch that video, because if you don't understand the basics, this video will be just a big waste of your time and my time as well, because if I teach and somebody don't understand, that's a waste of time for both of us. So just watch the basics or learn the basics before you hop onto this video. So log 27 to the base 3 is actually 3. Now let's jump on log 9 to the base 3. How much is log 9 to the base 3 is? So log 9 to the base 3 is equal to, it's pretty simple. We know that this 3 is the base, this 9 is the final output or answer, and this x is the power. So we can write in index form. It's very easy. The base 3 to the power x is equal to 9. So what will be the power of 3 if it equals 9? It will be 2, because 3 times 3 equals 9. So let me write the same question right here. Okay, so log 27 to the base 3 minus log 9 to the base 3 is equal to, so we know this is 3, why 3? Because 3 to the power 3 is equal to 27, and if you write this in the log form, it will be log to the base 3 to the output of 27 is equal to the power. So log 27 to the base 3 is equal to 3. That's why we got 3. And log 9 to the base 3 is 2, because 3 to the power 2 is equal to 9, and this can be written in the log form, that log to the base 3 to the output of 9 is equal to the power 2. So that's why it is 2. So 3 minus 2 is equal to 1. Now what is this 1? This one is basically x divided by y, log of the base a. So what is our base a here? Our base a is 3, 3, and 3. So which means log base 3, what is our x? 27. What is our y? 9. So log 3, 27 divided by 9 is equal to log 3 of the base 3. Now log 3 of a base 3, any log of the same base and log is always equal to 1. So that's why log 3, 27 divided by 9, which is equal to 3. So log 3 of base 3 is always equal to 1, which is also equal to 3 minus 2. Because when the powers are subtracted, our bases are divided. So let me show you a little bit more. Why this x and y is actually divided here. Let's take an example. 2 to the power 5 divided by 2 to the power 3 is equal to 2 to the power. Now when we divide two same bases, the law of indices tell us that their powers will be subtracted. So this is equal to 2 to the power 2. What is this 2 to the power 5? And what is this 2 to the power 3? This is equal to 32 divided by 8. So when the product of our bases are divided, our powers are subtracted. That's why when these powers are subtracted, because log 27 to the base 3 is actually the power of 3. And log 9 to the base 3 is actually a power of 2. So when we subtract the powers, we divide the product of our bases, which is 2 to the power 5 is equal to 32 and 2 to the power 3 is equal to 8, which is equal to 4, which is equal to 2 to the power 2, which is exactly what we got right here. So when two powers are subtracted, the product of their bases will always be divided, because if it is not division, the power would never be subtracted. Now let's take this question as an example. So what is log 64 to the base 4 equals to? So this we can write as 64 is equal to 4 to what power? So 4 times 4 is equal to 64. So we know that this power will be 3 because the base 4 has been multiplied 3 times. So this is equal to 3 minus, let's talk about log 16 to the base 4. Now this is equal to 2 because 16 is equal to 4 to the power 2. 3 minus 2, now this is equal to 1. Now why this is equal to 1? This is equal to 1 because log base 4, 64 divided by 16 is equal to log 4 of base 4. Now if the base and the log is same, this is always equal to 1. So we can say log 4 of the base 4 is equal to 1, which is exactly what 3 minus 2 is. Now one more time, why do we subtract the powers? Subtract the powers because we divide the product of our bases, which is 64 divided by 16 is equal to 2. 4 times 4 times 4 divided by 4 times 4 is equal to 4, because 4 goes 4 and 4 goes 4, so this is equal to 4 equal 4 to the power 1, which we can also write like this: 4 to the power 3 divided by 4 to the power 2 equal 4 to the power 3 minus 1. So when we subtract the powers, we divide the base or the product of the bases. That's the simple concept. Now, how will you find out the value of this log using a calculator? So this is equal to log 32 divided by log 2 minus log 16 divided by log 2, and you will get the answer of 1. Now why this is equal to this, why log 32 to the base 2 is equal to log 32 divided by 2? Now this is not yet a topic to cover. So before we do this, we should understand the basic concepts, and that's exactly what I'm doing in this video. And that